This is Mohlahlo MS from TVET College, Mbodozankomo campus. I'm teaching Electrotechnology N3 level. I'm using this textbook in our campus, which is written by Tony Ferreira. We're going to be going through chapter 7, which is transformers. A transformer, what is a transformer? A transformer is a device we use to step up or step down the voltage. We all need electricity in our lives, so electricity is being produced at a high voltage in our power stations. For example, you see the generation of electricity is done there and it is produced in a high voltage. So it is also transmitted in high voltage. The distribution, we only need a certain voltage, so we need to step it down or step up the voltage to accommodate everyone. So when they generate the electricity from the power station, the cables come through to the transformer. It enters in the primary side of a transformer. You'll have your cables line 1, line 2, and line 3. The cable from the supply doesn't go through the secondary side of a transformer, but we receive the cable from the primary side of a transformer. This will be the secondary side of a transformer. Remember, the operation of a transformer, you just need to apply a voltage into a transformer, and then there will be magnetic fluxes around the core. Then that will be linked with the secondary windings. There is no electrical connection between the primary and the secondary side of a transformer. It's entirely magnetically. So once you apply a certain voltage, the core will have fluxes and link the secondary side. It can either step up or step down the voltage. In this case, we will talk about one of the examples that I've already written there on the board. It's a three-phase. I would like to emphasize the three-phase topic because it's the one that is difficult for our students. A single phase is easier to understand, and I haven't had problems with the single phase with the students. It's mainly the three-phase that is complicating. To master the three-phase calculation, you need to know the four configuration of a transformer. We have a delta-delta connection, we have a star-star connection, we have a delta-star connection, we have a star-delta connection. These four are the configuration of a transformer. A transformer can be connected in either this format, delta-delta or star-star, or delta-star or star-delta. What is it that you need to know about when they say delta? What do they mean when they say delta? If it's a delta, you know that your V line and your V phase are the same, but the I line is the square root of 3 of I phase. Once you hear the word delta, you need to understand what does delta mean. It means this. If it is star connection, you know that your I line and your I phase are the same, but your V line is equal to square root of 3 V phase. Once you understand what does delta means, what star means, you won't have any problems in solving this type of calculations in a three-phase circuit. So we're going to go through this calculation together so that you understand how to apply the delta star format on this type of question. We are given a three-phase step-down transformer, has a delta-connected primary and a star-connected secondary. But we are given a configuration of a delta star. So our primary side, the same is delta. Our secondary side, we are given a star connection. The primary line voltage, they say the primary line voltage, which is our V line, it is equal to 66 kilovolts, which is the same as 66,000 volts. The secondary line voltage is 11 kV, which is the same as 11,000 volts. Neglecting losses, we calculate. By saying neglecting losses, it means you are dealing with a transformer which is ideal. When you talk about an ideal transformer, we talk about a transformer with no losses. Basically, this means that we are dealing with a transformer with no losses. So we need to calculate, number one, the transformer ratio. We have a formula for calculating transformer ratios. It says V1 over V2 equals to N1 over N2 equals to I2 over I1. Current will be inverse. So in three-phase, you only use phase values when calculating using this formula. You do not apply a line value in this type of formula. So all the values that you substitute here, it must be phase values. In this case, they want us to calculate the transformer ratio. The transformer ratio is V phase 1 over V phase 2, meaning it's V1 over V2. But you do not use the lines as you are given from the statement. We only want to use the phase values. How can we find the phase values? In a delta connection, you remember in delta, V line equals to V phase, meaning we do have a V phase in this primary side. So the V phase will also be 66,000 volts. But in star, V line is not equals to V phase. So we need to calculate the V phase because we need the V phase in both primary and secondary sides to be able to calculate the transformer ratio. So in this side, V line equals to square root of 3, V phase, meaning our V phase will be V line divided by square root of 3, which is 11,000 divided by square root of 3. And that gives us a total of 6350, 853 volts. Now that we have V phase 1 and V phase 2, we can calculate the transformer ratio. We substitute here, our V phase 1 is 66,000, our V phase 2, we just calculated, it's 6350, 853. Then our transformer ratio will be 10,91, 10,39 is to 1. We have solved the first question for transformer ratio. Number 2, they want us to calculate the primary line current if the secondary current is 500 amperes. From the secondary side, we are given I line as 500 amperes. You check your star connection. In star, what does it say about line and phase current? It says line current equals to phase current, meaning we do have a phase current on the secondary side. Our I phase equals to our I line, which is also 500 amperes. So we do have I phase from the secondary side. We can use this formula to calculate the current. We can use the set of voltages and the set of currents to calculate the I phase from the primary side, because we are only using phase values when substituting on this formula. We cannot substitute naming the current as I line. That's why we say I line equals to I phase, which gives us the access to use the 500 because it is I phase in a star connection. So V phase 1 over V phase 2 will be equals to I phase 2 over I phase 1. We need to find I phase 1. So our I phase 1 will be V phase 2 multiplied by I phase 2 divided by V phase 1. We substitute because I think we have everything that we need for this substitution. Our V phase 2 is 6350, 853. Multiplied by I phase 2, which we are given as 500. Our V phase 1 is 66,000. Our answer will be 48,113. 48,113 amperes. But remember, this is the phase current from the primary side. They did not ask us to calculate the phase current, but they actually wanted the line current. So you need to check how you can find the line current. It's a delta connection. The primary side is delta. How do you find a line current? We're going to use this one for currents because they want actually the line, not the phase. So from there, it says I line equals to square root of 3 I phase. So we do have the I phase, we need the I line. It is square root of 3 multiplied by 48,113, which gives us the value of 83,33 amperes. So we do have what they wanted here. The transformer ratio is 10.3139 is to 1. The primary line current is 83,333 amperes. What is important is to understand which side or what information are you given from the statement. All the information that you are given and they say to you it is from the supply, you must know that it's from your primary side of your transformer, because when the transmission is happening from generation point to distribution, the cables go through the transformer through the primary side. If it's from the supply, it means the cable is from the primary side. All the values that you're going to be given that are from the supply will be on the primary side of the transformer. But it becomes tricky for students to understand because sometimes the question will say there is a certain voltage that supplies. If it supplies, it will be the secondary side of a transformer because now it is supplying. If it delivers, it must also be on the secondary side of a transformer because you cannot deliver a certain voltage from the primary side of a transformer. You can only supply a transformer from the primary side and then you deliver it from the secondary side to the consumers. You cannot put a cable from the supply in the side, the secondary side of a transformer, and then supply consumers to the primary side of a transformer. So this is your supply side. Even if they did not mention that the primary line voltage is 66,000 from the primary side, they will just say the supply has 66,000 volts. You must know the voltage that's from the supply is your primary side of your transformer. Please go through your exercises 7.1 and 7.2 as well, and do the single phase part. I know you understand it because you did it in N1 level, N2 level, and it's also here on N3 level. I think that is why it's easier for students to understand. The 3-phase becomes more complex at this level, but it is very easy for you to understand once you master these configurations and this formulas that separates the delta and the star connection. In the meantime, keep safe, social distance, sanitize, and always put on your mask. Thank you.